All right, so the last objective here is talking about what are mutually exclusive events. So two events are considered mutually exclusive if together the events have no outcomes in common and can never occur together. So mutually exclusive, kind of a big deal, right? Two events have no outcomes in common. That is the probability of A and B, and meaning occurring at the same time, is 0. There is no chance that these two events happen at the same time. Now, there is an addition rule for mutually exclusive events. This addition rule has to do with A or B. So say I want A or I want B. What's the probability? Well, because they don't occur at the same time, you just take the individual probabilities and add them. The probability of A plus the probability of B. So again, these are where the events have no overlap, nothing in common. And again, this rule only works for mutually exclusive events. In the next couple sections, we're going to talk about non-mutually exclusive events and how we handle them. Okay. All right, example 3. Is it easy to pass the AP exam? Randomly select a student who took the 2015 AP Statistics exam and record the student's score. Here is the probability model according to the College Board. Many people consider the scores of a 3, 4, or 5 to be passing. So 3, 4, or 5 are passing because many colleges award credit or placement to students from these scores. Find the probability that the chosen student scored less than a 3. Less than a 3 means you scored a 1 or you scored a 2. So the probability that I scored less than a 3 is equal to the probability of a 1 plus the probability of a 2. I'm going to add 0.236 plus 0.186. And again, I simply add them because you either get a 1 or you get a 2. You can't get a 1 and a 2 at the same time, and we get 0.422. So you have a 42% chance of not passing, right? This would be not passing. Now we're going to find the probability that the chosen student earned a passing score. Well, a passing score is a 3, 4, or a 5. So now we're looking at this group, 3, 4, or a 5. So the probability of passing is equal to the probability of 3 plus the probability of 4 plus the probability of 5. And that's going to be a 0.252 plus 0.191 plus 0.135. When I add those three numbers together, I do get 0.578. 578. Now, again, this is the probability of not passing, and this is the probability of passing. So if you were to combine these two together, right, 0.422 plus 0.578, that would equal 1 because you're either going to pass or you're not going to pass. There's no other way around it, okay? So keep that in mind too. We could have done 1 minus. We could have also done 1 minus the probability of getting less than a 3. 1 minus 0.422, which could have also gotten us 0.578. So there's sometimes more than one way to do the work. That's why math is beautiful, but also aggravating at the same time. All right. Good luck on the homework.